This is question 13 from exercise 3.5 in text and test 4 new edition. The diagram shows a cube of side 10 centimeters from which one corner has been cut. We have to calculate the angle PQR correct to the nearest degree. So the angle PQR is going to be in the triangle PQR, which is going to be what's left flat on the corner of what used to be a cube. So when the corner is removed, it's just going to be that flat triangle that's left against the cube. But before we do that, we're going to have to deal with the other triangles in order to get the length of the sides of the triangle PQR. So if we look at the triangles that were there before, so we'll imagine this corner of the cube up here is called S. We'll give it the name S. And there are three triangles that share that corner S. There's the triangle QSR, the triangle PSR, and the triangle PSQ. And all three of those triangles are right angled at S. And on top of that, we've also been given the lengths of those sides. Because we know that the cube is of length 10, which means that the line QS has to be 5 centimeters. And we've been given the length of the line here, so we know that RS is going to be equal to 6 centimeters. And we know that PS, by the same reasoning, is going to be 8 centimeters. So we have three right angle triangles, which if we knew the lengths of their hypotenuse, we would know the lengths of the three sides of the triangle PQR. So we're just going to have to go through the motions to get that. So let's just take a look here. So we will start with the length of QR. So QR squared is going to be equal to 6 squared plus 5 squared. So if we just calculate that down, we're going to get equals to 36 plus 25. So QR squared is going to be equal to 61, which means QR is going to be equal to the square root of 61. And it'll actually be far more convenient for us to leave this in surd form. And you'll see why when we get to the cos rule that we're going to do to get the length of the angle PQR. Next up, we'll do PQ. So PQ squared is equal to 8 squared plus 5 squared. So PQ squared is equal to 64 plus 25. PQ squared equals 89. And again, we're going to need this in the surd form. PQ is equal to root 89. And then for the very final one here, for the length of PR squared is equal to 8 squared plus 6 squared. So PR squared equals 64 plus 36. PR squared is equal to 100. So PR is equal to 10. Okay. So now that we've got that drawn, let's just draw a quick diagram of our triangle PQR so we can see what we're dealing with here. So we have P, Q, and R. The angle in question that we're being asked for is just here. It's the angle Q. So PQ is length root 89, PR is length 10, and RQ is length root 61. And our sine rule is a squared equals b squared plus c squared minus 2bc cos a. And you can see that if we have all three lines in a triangle, then we can use the sine rule to get the measure of one of the angles that's left behind. That's exactly what we've got here. We need one of the angles, we've got the three sides. So the sides that are going to match up for this, B and C, are going to be root 89 and root 61. Side A is going to be 10, and cos A is going to be the cos of angle Q. That's because you notice in the cosine rule, the side and angle that start and end this rule are going to be the same letter. They're going to correspond to each other. They're going to be opposite each other in the triangle. So we put this together with what we have from our triangle, trying to get this angle measured out. It's going to be 10 squared is equal to root 89 squared plus root 61 squared minus 2 times root 89 times root 61 times the cos of q. So as we multiply all them out, we get 100 is equal to 89 plus 61 minus 2 root 5429 times the cos of q. And if we move some stuff around, you get 2 root 5429 cos q equals 89 plus 61 minus 100. So 2 root 5429 cos q is equal to 50. Then we just do a little move. We're going to move the 2 root 5429 over. So the cos of q is equal to 50 over 2 root 5429, which means that q itself is just going to be equal to cos inverse of that fraction. So q is going to be equal to 70.165944745 degrees, but the question asks us to get this to the nearest degree, so q is approximately 70 degrees, like that. And that is that.